Welcome to class. Before we can go into solving mathematical problems that involve sorts, it's important that we get to understand what sort is, its types, the types of sorts, and the rules that guide it. Okay, so this is what we are going to be looking at in this class. So this is an introductory class to sorts. Let's start with this. So what exactly is sort? For us to understand what sorts are, I'd like us to take a look at these examples. Okay, let's take a look at these numbers. If you take a look at this number, you're going to notice something. To find the square root of 1, you simply get 1. To find the root of 4, you simply get 2. And to find the root of 9, you're going to have 3. And then that of 16 gives you 4. If you take a look at these results we got, you're going to notice they are whole numbers, right? We don't have decimal numbers. So we can call these, the whole of these, we can call them rational numbers. Or we can equally call them exact numbers. They are called rational and exact numbers because when the result we get are whole numbers. Okay, we don't we get the exact numbers, we don't get decimal numbers, so these are whole numbers. However, if you take a look at these two here, you're going to notice something. The square root of 2 gives us 1.414, and the square root of 5 gives us 2.236. You can see that this is not occurring in a whole number, is occurring in decimal form. So we can call these irrational numbers. So now that we've understood these, sorts are simply numbers that when you further simplify them, you cannot get a whole number. You end up getting decimal numbers. And these decimal numbers, we can equally call them irrational numbers, okay? Because they do not appear as whole numbers. We don't get the exact numbers. It's continuous. So that's exactly what sorts are. So we can simply say sorts are numbers that when simplified, we get irrational numbers. Now that we have known that, let's take a look at the types of sorts we have. Ideally, we have a lot of sorts, but in this class, we'll be looking at 7 types of sorts briefly. So first of all, we have what we call the pure sorts. So when you talk about pure sorts, they are sorts that have only one rational number. For example of pure sorts are these. We have root 2, root 3, etc. So if you take a look at these, they only have one rational number. They don't ever have more than one rational number. The second one we have is called mixed sorts. Mixed sort. So when you talk of a mixed sort, what is a mixed sort? It's simply a sort that contains a rational number and a root. It contains a rational number and the root. So you're going to have something like this: 3 sort 5, 4 sort 7, 3 sort 8, and so on. So when you have something like this is referred to as a mixed sort. We have the roots here and we equally have a rational number. So a mixed sort is a combination of the root and the rational number. Another one we have is called similar sorts. Now when you talk of similar sorts, all their roots are the same. Okay, they have the same root. For example, you can have something like this: root 2 plus 3 root 2 plus 4 root 2. If you take a look at the roots here, they are all the same. All right, so that means they are what? Similar sorts. That's what similar sorts are. They all have the same root. Then when you talk of dissimilar sorts, there's sorts that are not similar. It's simple, right? Because it's just the opposite of this. When you have sorts combined and they have different roots, that is what we refer to as dissimilar sorts. For example, we have something like root 4 plus 3 root 5 plus 5 root 7. If you take a look at the roots, you can observe that they are totally different. They are not the same. So you can say they are dissimilar sorts. Another type of sword I would love to mention is the monomial sword. Monomial. Now, this from the word mono, we know we are talking about one. So, monomial swords are simply singular swords. They occur in one, almost similar to the pure sword. So, you have things like this, and you have this. So, this is referred to as the monomial sword. Another one we have is the binomial sword. So binomial sword is a combination of two monomial swords. When you have something like this, sword 2 plus sword 7. This is a binomial sword. They occur in two pairs, okay? So you're having sword 2 plus sword 7. Then another one we are going to be looking at, we are going to be looking at the conjugate sword. Conjugate sword. For us to understand conjugate swords, let's take a look at binomial swords. So when you know binomial swords is a combination of two swords, okay? When you sum up or subtract two swords. So if we have something like this, for us to know the conjugate of this sword is simply the inverse operation of this plus, okay? So conjugate swords have the same swords, okay, but there's an inverse in the sign, okay, the inverse operation. So where you have a plus, you're going to have a minus. So we can simply say the conjugate of this number is sword 2 minus sword 7. So that's simply what conjugate swords. There are swords that are the same but differ with the sign only. All right, the sorts are the same, the roots are the same, but they differ with the sign only. So this is it for now. There are many more sorts, but I would like to stop here. At least this will be useful in when we begin to solve mathematical problems involving indices. So now that we know the types of sorts, we've looked at what sorts are, its type. The next thing we are going to be looking at are the laws, or rules rather, the rules guiding its operation, okay? The rules guiding the operation of sort. In looking at the rules guiding the operation, I would like us to start with the multiplication rule. The multiplication rule. Now, when you are looking at the multiplication rule, what it simply states is this. The multiplication rule tells you that when you have root b times root c, it's equals to the combination of the roots, that's b times c, okay? Root b times root c gives you a combination of the root b times c. Let's impute some numbers and check if that is true. So if you have root 9 times root 16, okay, let's check if we are going to get if this law is true. So we are going to have 9 times 16. So the square root of 9 is 3 times the square root of 16 is 4. Then this is equals to 9 times 16 gives us 144. All right, it gives us 144. Then looking at this, if you say 3 times 4, it gives us 12. And we know that the square root of 144 is 12. So you can see that this rule is true and it works. Okay, so whenever you are multiplying sorts, okay, of different whenever you're multiplying different sorts, you can combine them and still get the same answer. That's what this very rule simply means. Okay, so now we've done this, let's take a look at the division rule, how it works. Now when you're talking about the division rule, what it simply states is this: if you have root b divided by root c, the division rule tells you that this is equals to the combination, okay, of the roots, like combining them this way. So it tells you this is equals to this. And this division rule is very useful when you have numbers that are not perfect squares, okay? For example, if you have b and you have c, and the numbers are not perfect square, it becomes easy to combine them and then you're able to find the square root. But in a situation where you don't have numbers that are not perfect square, it may not be necessary to apply this. Let me give you an example. If we have sod 32 divided by sod 2, you can see that these are not perfect squares, okay? So we can simply combine them. By the time we combine them, we're going to have 32 divided by 2, then we find the square root. You're going to have the square root of 16, right? And then this gives us 4. So this division rule simplifies sorts that are not perfect square. That's when it's so necessary to apply it. Okay, but when you have something like this, maybe you have sort 16 over sort 9 is equals to 16 over 9, okay, finding the square root. Now when you have something like this, you see that this law is not necessary here because we have two perfect squares. Because by the time you find the square root of 16, you're going to have 4 over the square root of 9 is going to give you 3. So we already sorted it out. But if we decide to apply it here, when we say 16 divided by 9, you're going to see that we're going to be getting decimal numbers. And that is not what we want to achieve. So you can see that this is suitable when you have numbers that are not perfect squares. So now that we've taken a look at the multiplication rule and the division rule, let's take a look at the addition rule. Let's take a look at the subtraction rule. Now when we talk about the addition rule, what it tells us is this: when we combine two different sorts, when we sum like sort b plus sort c, we do not get the same thing when we combine the sorts. So what this rule simply says, sort b plus sort c is not equals to combining it, like what we had in the multiplication rule. In the multiplication rule, you can multiply different roots or different sorts together and you get the answer. But in the addition rule, you cannot multiply different sorts together. They are not equal. You're not going to get the same answer. Let's impute some numbers so that we can understand. So if we have sort 16 plus sort 9, then what do we have here? We have 16 plus 9. Okay, so you're going to see that by the time you find the square root of 16, you're going to have 4 plus the square root of 9 gives us 3. And this, when you sum 4 plus 3, gives us 7. Now let's take a look at this place. When you say 16 plus 9, you're going to get 25. Alright, so the square root of 25. By the time we find the square root of 25, we're going to have 5. You can see that these two answers are not the same. So we can equally say that the additional rule does not support addition of different sorts. Okay, so we can see that these are not equal. All right, we are getting different results. If you must add sorts and get an answer, they must be the same sorts. For example, if we have sort A plus sort A gives us 2A, you can see these two are the same. You can think of it this way. If you say 6x plus 2x, you get 8x, right? Because these are like terms, so you can sum them up. But however, if you say 6x plus 2y, you don't get, it's not possible to sum them up because they are not like terms. So that's exactly what is happening in this addition rule. You can only add sorts that are like terms. Okay, in this case we have A plus A. So if we have something like, let's impute a number. If we have sort 4 plus sort 4, okay, now we are going to have 2 sort 4. You may be wondering, where are we getting these two from? If you take a look at this source, there's a 1 we don't necessarily write. Okay, it's the same as saying 1 times sort 4 gives us 1 sort 4, but we do not write this one, just like we don't say 1x, right? But there's a 1 in front of the x, we simply say x. It's the same thing occurring here. All right, we don't necessarily write the 1, but it is actually present. The fact that it doesn't appear doesn't mean it's not present. So you can add the same sort and get your answer. That is what the addition rule states. So now that we've taken a look at the addition rule, how about the subtraction rule? So just like the addition rule, the subtraction rule is similar. Okay, here's what it states. It says when you have root b minus root c, it is not equals to the combination of the roots. It is not equal. So let's impute a number here so that we can understand how this rule works. For example, if we have sort 16 or root 16 minus root 9, okay, what this is telling us that it is not equals to having a combination of 16, the square root of 16 minus 9. No, it's not the same thing. Now let's solve and see what we are going to get. We are going to have the square root of 16 is 4 and the square root of 9 is 3. Okay, so what do we have here? By the time we say 16 minus 9, we are going to have 7. And if we are to find the square root of 7, of course we are going to get a decimal number, right? We are going to get a decimal number here. But if we find this, we say 4 minus 1, we have 1. So you can even see from here, without even trying to find the square root, we know that 1 is not equals to 7. Okay, so in the subtraction rule, you cannot subtract sorts that are different. Okay, they have to be the same. Let's look at what happens when we have the same sorts. If we have something like this, sort b minus sort b, okay, this can work. It still equals to sort b minus sort b. Okay, now let's impute a number here. Let's say we have root 16 minus root 16. Okay, it still equals to 16 minus 16. So by the time we check it out now, you're going to see, by the time you say what is the square root of 16, you're going to have 4 minus the square root of 16 here, you're going to have 4 equals to, by the time you find the square root of this, this is going to give you the square root of 0, and 4 minus 4, you have 0. And the square root of 0, it still gives you 0. Okay, so you're left with nothing. You can see they're equal. So just like the addition of sorts, okay, the subtraction of sorts is possible when you have only similar roots. Let's take a look at another example. When you have something like 2 sort 4 minus sod 4. Because we have similar roots here, okay, we have 4 here and we have 4, so we can just subtract. It becomes this 2 minus the 1 we don't write here. We get 1, which we don't necessarily need to write. So we have sod 4. Okay, so our result is sod 4. So we've taken a look at what surds are, its type, and the rules that guide it. So in the next video, we are going to be looking at how to convert pure surds to mixed surds, and how to convert mixed surds to pure surds. So this is it for this video. If you got value from this video, do hit the subscribe button. If you've not, share with friends and loved ones. And don't you ever forget, math can be easy. I'd love to see you in the next video. Thanks for watching.